This is one of those lessons that if you get the idea of what's happening, if you understand the gist of what's going on, you should find most of the homework pretty straightforward. So I start with an example to try and motivate you to why we do what we do in this particular example. So I want to talk about my dream retirement plan here. Not that I'm close to retirement. Yeah? I got a ways to go. But it's a good example to use. Let's imagine that what I do is I buy a Subway and a Burger King. This would make my life. I would love to run little restaurants like this, you know? Hire people, put people on shift. You know, this is sort of my dream finish of all this. So let's imagine for a second I have a Subway and a Burger King. And I want to keep track of how we're doing as far as how much money we're making. And don't worry about the actual numbers. I don't know if these numbers are accurate. I don't know how much Subways make or how much Burger Kings make. But so let's say I get up there and I go up to month 1. And I go to the Subway and I say to the manager, how much money did we make last month? And he says, oh, yeah, we did good. We had a good month. We made $300. Hopefully my Subway will do better than that. But, okay, $300, okay? And then I go over to the Burger King and I say, oh, how much did you make? I say, oh, well, we had a great month. Yeah? $500. If I wanted to make a new column and find out what's my total, yeah, come home and tell Mrs. Todd how our businesses did. It's not a tough question. And there's no trick here. But I hope you would agree I'd just take the 300 and add the 500. And we're already a couple minutes in, and I'm already at the complete biggest point of the lesson. If you want to add two functions, you add the y values, and you keep the x value the same. Yeah? And might actually give you a bigger picture of why we're always talking about the x value of maxes and mins. The x values, the intervals of increase and decrease. Because the x value is usually, when did it happen? Yeah? And then what happened? 300 for the first function. Maybe this will be f at x. 500 for the second function. Maybe that's like g at x. And then my total is f at x plus g at x. And I'll say my important sentence again, and then you can probably go to sleep for a while. Well, you know, I don't mean actually go to sleep where your brain goes, oh, okay, I got this lesson down pat. When you want to add two functions, you add their y values at the certain x value that you're talking about. I'll do a couple other months just to illustrate a couple little things that could come up. The only other things that could come up is, let's say month 2 I go and I go to the Subway manager and I say, how did we do last month? She says, well, you remember we did all those renovations. We had a lot of things to buy. You know, we fixed up the bathroom and everything like that. So I don't want you to be mad, but we lost $400 that month. But everything's all fixed up now, so now it's going to be good. I'm like, okay, that's no problem. Yeah, I knew that. And then I go over to Burger King and I say, okay, what happened? I said, well, it's good. It wasn't great. It wasn't as good as last month, but we made $300. Then I'd take these two y values and I'd go 300 subtract 400 equals negative 100. And the analogy's not perfect. I'm just trying to get the idea that if it says subtract the two functions, then you subtract the y values. And I know I'm adding a negative here. I get all that. I was just trying to get negatives in there a little bit so you get the idea. If one of them is negative, that's fine. You still put them together at a certain y value, but you keep the x value the same. That's the important sentence. Okay? One last little detail. Month 3. Go to Subway and say, oh, great month. You know, those new improvements, people are loving the new store, blah, 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 $700 I make. I go to the Burger King manager and go, okay, well, here's what happened. You know, we had that little problem with the fryer. Yeah, we don't know what that's going to cost yet. And all the receipts aren't added up because we were so busy trying to scramble with the old fryer and do repairs. I'm sorry, but all the accounting is not done yet. I can't give you an answer yet. I haven't got it figured out. And this happens in accounting all the time. You get to the end of the month, and you're like, I don't know. I don't know what the answer is yet. I'm working on it. Give me another day or two. Miss Dodd, I come home and I say, she says, how did we do? What's the total for the month? And I'd say, I don't know. You know, because I don't know. And you might say, well, you could at least tell her it's 700 plus. I'm like, yeah, but it's 700 plus. There might be minus. We had to get a new fryer. I don't know. And so what we do in mathematics, if we don't have one of the pieces of the puzzle, we don't try and guess here in mathematics. For you potential accountants and business people out there, like, well, we could talk about it. We could write something down here. I totally get that. That's not a math move. That's an accounting move where you try and explain part of what's going on here. So in math, if we don't have the data, to do part of the answer, we don't finish it off in this particular situation. I don't want you to overread that too much. Just be aware in the homework, if you get to an x value and one of the y values isn't there, don't include it. Don't put it in your information. That's how we'll handle it here. Okay? Oftentimes this means undefined. You know, it's a restriction is why this happens in math. And then you really can't do anything with this. So just fair warning, do it my way until you know more about it. Any questions about that? Pretty straightforward example. And gives you all you need to go through this lesson probably pretty quickly. Here's the slideshow. I forget how many slides it is. Is it 6 again? 6 slides, wrap up the chapter. Work period tomorrow. And start to think about your test prep, how you're going to handle that. Anyways, exploring operations with functions. Suppose we had 2 functions, f and g. Subway, Burger King. Yeah? I like Subway and Burger King. I really should change the example to something that starts with F and starts with G, right? What 2 businesses could I own? I own a Foodland and a... What business could I buy that starts with G? You think about it. A garage, yeah? In the mall there. A Foodland and a garage, yeah? Okay. Gino. Oh, better. Gino's better for me. I'm not going to own a garage. Jeez, okay. Okay, so let's think about what f at x plus g at x means. Here it is in fancy language, not in my little example language. In fancy language, let's consider the case where x equals 2. So in our example, that was month 2. Maybe you think of it as February, maybe not, just the second month I own this thing. If we wanted to find f at 2 plus g at 2, we simply evaluate both functions at x equals 2 and add the results. You keep the x value of 2. It still happened in month 2, but what was the result? Whatever the 2 values were. Whatever Foodland and Gino's made that month, I add their 2 totals up. A few things to think about with f at 2 plus g at 2. Notice that is the 2 output values, the y values we're actually adding here. And notice we're adding the output values that correspond to a single input value. That is, if we substitute x equals 2 into f at x, we also substitute x equals 2 into g at x. So we're keeping the x the same. I'm saying it a zillion times to bore you. Yeah? Keep the x value and do the operation on the f and g. Now notice I've changed my words there. Not just adding, any operation you want to talk about. You add, subtract, multiply the corresponding values. Notice I didn't mention divide. Divide's a big problem. It's got that dividing by 0 thing in here. So you'll notice in the homework. Today we're going to do add, subtract, and multiply, and we'll leave dividing on the shelf. Chapter 5, we'll talk about what are we going to do if it's divide? You know, okay, so. All right. Notice we can only perform this addition if 2 is in the domain of both f and g. That's what I said at the end. If 2 is not in the domain, we just ignore 2 completely, and we don't report on what happened at 2. Let's get to the point. Well, let's get to all the points. When we add 2 functions, we add the 2 output values for each valid input value. We can only add the functions where the domains overlap. The same idea applies to subtraction and multiplication, and we're going to leave division on the shelf for a while. Some examples. Say they give you this information, and again, you could totally relate this to the opening example. Month 1, we made $2,000. Month 2, we lost $3,000. Month 3, we made $4,000. 5, 8, 6, -7. All this data. If we wanted to find f plus g, we just go through the individual points, keep the x values, add the y values. So, month 1, they both made 2. So my new function has 1, 4 in it. Month 2, -3 and 5, that adds to 2. Month 3, 4 and -6, that adds to -2. Month 4 is missing because I don't have month 4 for both sets of data. And we can argue at that, but that's the way we're going to handle it in math for now. Is go if the data's not there, we just leave it out of the final answer. We can do month 5 because I have the information for both month 5s there. 5, 11, I added the 8 and 3, and month 6 I leave out of my final answer because I don't have all the data. Do you have any questions on that? Yeah, 4, -8 didn't have a matching one here. So from the example, G, Gino's Pizza, month 4 lost $8,000. When I went over to Foodland, they didn't have their data for month 4, so I just leave that out. And don't include it in the final answer. Even though, yes, I know, and what accountants would do with this actual, to follow the analogy through, is then they'd have over here, they'd have some more information. By the way, in month 4, here's where we're at. You know, they'd include some talk about what the heck is going on there, about why 4 wasn't included in the answer. For us, we just leave it out and say, here's the definitive answers we have. We know this for sure, and that's all we leave in there. Lots of times what's happening is that in math, that other value is undefined, and we won't ever be able to get it. And so it's going to have to be dealt with differently than that math. Yeah. If you want to do f minus g, it's all the same stuff, except you're going to take f and subtract g. How does that fit with my analogy? Maybe this is how much, the f is how much money came into the store, and g is how much money I had to pay in wages. So instead, you're subtracting the two at every particular month. So the analogy follows. Why would we'd be subtracting? And so in month 1, 2 minus 2 is 0. In month 2, negative 3 minus 5 is negative 8. Analogy sort of falls apart there. Why would you be going negative 3 minus 5? Okay, but that's not the point. The point is take these y values and subtract them. 4 minus negative 6 is the 10, and 8 minus 3 is the 5. So you go through there, and instead you subtract the y values instead of adding the y values. Notice I end up with the same x values as I did before, because those are the points that are in the overlapping domains. The x values are in both domains. Any questions about f minus g? I'm not trying to go fast on purpose. I'm just trying not to bore you with something that might be like, okay, I totally get what we got to do here. Keep the x values, add or subtract the y values, get on with our day. Yeah? G minus f. Well, you could go back and do it, but there's an easier way. If f minus g was 0, g minus f is 0. If f minus g was negative 8, g minus f is positive 8. You know, it's just subtracting the other way. So you could get to the answers fairly quickly, but you don't have to. You could go back to here and go, okay, g minus f, 2 minus 2, that's 0. Okay, and then for month 2, 5 minus negative 3, okay, that's 8. Month 3, negative 6 minus 4 is negative 10, and 3 minus 8 is negative 5. The other ones I leave out because I don't have all that data. F times g, exactly the same, except you're now multiplying the y values instead of adding or subtracting. So 2 times 2 this time is 4. Negative 3 times 5 is negative 15. 4 times negative 6, negative 24. 8 times 3 is 24. I did it on purpose with just points there to get the feel for what's going on. And then we'll do it in a second with equations and with graphs to see what goes on with those. Any questions on f times g? We leave f divided by g out because, if there was a 0 in here, there isn't a 0 in here anywhere. Since there's no zeros, we could do f divided by g right now. But as soon as there's zeros, our world blows up, and it's going to need some thought of what to do about those zeros. Okay? So we leave that out for now because we do so much analysis of that in chapter 5. We're going to really get to the bottom of this dividing by 0 thing. How does the domain of each of the results compare to the domains of the original functions? Oops, that's not what I wanted. I wanted the right click there. I'll get a pointer. The new domain is the overlap. It's where they had x values in common. You've got to have x values from both functions before you can come up with an x value for your new function. Two more slides. How to do it with equations and how to do it with graphs. You'll find equations way easier than this, I think, and you'll find graphs a little bit more tricky. So back and forth we go. More time to write down the new domain is the overlap. All right, slide 5 coming at you. How to do it with equations? It's even easier. If f at x equals 7x plus 5 and g at x equals 9x minus 12, if you've got the equations and they ask you for f minus g, you just take f algebraically and subtract g algebraically, right? This is no problem. Yeah, then there's no big idea problem here at all. You just write down f the function, 7x plus 5, and you subtract g, the function 9x minus 12. Watch out with your negatives here, right? There's a subtracting negative popping its head in here. So you got to practice your algebra here, but the idea is pretty simple. Subtracting functions algebraically, pretty nice stuff. Let's see, I get 7x minus 9x, 5 plus 12, collect some like terms, negative 2x plus 17. There is a big idea to understand here, though. If I subtract or add two linear functions, I end up with a linear function. No matter what your mx plus b is, if you add another mx plus b to it, you're going to get a new mx plus b. So adding or subtracting linear functions keeps the exponent the same, and so you end up with another linear function. That does come up in the homework once, where you got to think it through and go, what am I going to end up with here? And if it's a line plus a line or line minus a line, it's still going to be a line, because all you're going to have is x's and numbers. Okay? F times g. Different game, not tough algebra, but if the algebra is easy for you, start thinking about my interpretation of this. What's a line times a line? What kind of thing am I going to get out of there? And the algebra helps here. Now I've got f, the function 7x plus 5, times g, the function 9x minus 12, and then I need my FOIL move here to multiply this out to see what I got. And what do I have? A mess is what I got. Multiply the first term, 7x times 9x, I get 63x squared. Multiply the outside terms, 7, maybe you want to draw the arrows on here if this is not exactly ringing a bell for you. Multiply the outside terms to get negative 84x, the inside terms to get 45x, and the last terms to get negative 60, collect like terms, and I get a monster of an equation. I do not want to graph this. The completing the square on this would be a complete nightmare. So even if I was to make you complete the square on a test, it wouldn't be one that looked like this. It would have 2s and 3s, 4s maybe. You know what I mean? Like, so let's not freak out about this thing. But let's talk about, if I could graph it, what kind of shape would I see from something that has x squareds in it? That's a parabola. And so the big point I want to get to on this slide is, if you take a line and multiply it with another line, or better yet, if you're taking x's and multiplying with them x's, you should expect x squareds, and you should expect a parabola when this is all over. That also comes up in the homework. You're like, what should I expect here? Line times line equals parabola. That sounds like I'm making a cheat rule there, and I'm not. That's a for real thing. Said more carefully, when you multiply x's with x's, you'll get x squareds out of there, usually. Yeah. Any questions about that one? I think there is one in the homework that challenges you to try and graph a simple one of these, so check that out. That's good fun on a Thursday, for sure. Questions here? More time? Okay, last one is a graphing one. Use the graphs of f and g to sketch f plus g. And this is harder, but easier once I explain it. When you first look at it, you get two lines like this. You're like, how am I supposed to graph these? You could find the equation. Again, there's a homework question where maybe the easiest thing to do is just find the equation. But see where this line goes through? It doesn't go through y equals 3, or it doesn't go through an intercept of 3, and this one doesn't quite go through an intercept of 4. So finding the equation of these is no joke. Yeah? So what you can do to get a graph of the line, how do I know it's going to be a line? These are both lines. If I add them together, whatever their equations are, I'm going to get a line. If it's a line times a line, then I should expect a curve. I'll need more points. But if I'm doing a line, I don't need 2 points. As long as I can get 2 points here, I can graph this thing. So one x value, that's a good one to use. And you get to just choose here a couple x values. Negative 5 is a great x value to choose because I know the red function f is 1 and the blue function g is negative 3. And let's see, 1 plus negative 3 is negative 2. And I know on my new function at negative 5, this line should have a point at negative 2. I'm halfway done at that moment because I know it's a line. As long as I get 2 points on a line, I'm done. When you get one in the homework that asks for, a line times a line, you should get a few more points to get the curve, because you know it's a parabola. You won't get the whole parabola, but get a few points. So 3 or 4, I'll say. I won't make a rule there, but you better get 3 or 4 points. But for a line, 2 is enough. So I get some other x value here. Where's a good choice here, where the y values I can estimate pretty well? They chose x equals 7. At x equals 7, f is right at 5, and g is right at -6. If you have to estimate here, this really isn't, we're not trying to torture you here. I'm not going to look at it and go, oh no, that was 5.2. Oh no, that's wrong. No, I'm trying to get an idea across here. Around 5 plus around -6 is around -1, and I've got my second point, and that's more than enough to draw the second line. Now, this question doesn't challenge you by making one line wider than the other. These have the same domain. You'll have to watch out for that. If one line only goes from here to here, then that's the only part of your new line you'll do. Okay? So there's some domain issues here, but I'm not really trying to torture you there. The homework will torture you a little bit. But as you're doing it, you're like, okay, yeah, I get it. I should only draw the line that far. Okay, I'm okay. But my big plan isn't to torture you with this. It's a small idea that we need here. Adding, subtracting, and multiplying basic functions. Yeah. Any questions about that example? If you know it's a line, 2 points is lots. If it's not a line, you better get 3 or 4 just so you can get the shape of the curve a little bit better. Yeah. An estimation is fine here. Totally fine. Question for discussion. Let's see if I discuss these questions for discussion or not. Would the graph of f minus j look the same as g minus f? No. If you're subtracting it the other way, you get the opposite answers, which actually tells me what it would look like. It would be a vertical reflection. It would have ended up over here because all my positives would be negatives, all my negatives would be positive. Okay. What result would you expect to get if you were to sketch the graph of f times g? What kind of shape would you expect if I did f times g? It's going to be a parabola because it's degree 1 times degree 1. I'm using some fancy words from later in the course there, but basically exponent 1, I'm going to get some exponent 2. And then if I was doing that, 2 points isn't enough. I better get some extra points here to make sure I get at least a little bit of the shape of the parabola. But I shouldn't be surprised when it curves a little bit because it's a parabola, not a line. I think I've said that a couple of times on purpose just because I know what homework question you're going to ask. I know when you get to that homework question, you're like, how many points are you here? So here, 3 or 4 should get you the shape. Oh, that's it. All done. Have a great day.